What exactly is your program is?
We're LJ Create. We've been in education for an awful long time. We produce engineering and automotive hardware and software for schools and colleges around the world. Our current product line, which you can see here, is training for electric and hybrid vehicles. Like them or not, electric and hybrid vehicles are part of the future, and they're not going to go away. I mean, they might not be the whole future, but they are going to be there. And so students of today need to learn how they work for when they're coming on to fix them and when they're working on them in the future. And the students are complaining that they have to do it. Of course they are, because it's different, but they do have to, and it's going to give them a massive advantage because they're going to go into the workforce already trained up on something that their peers perhaps don't have. So the issues that students find learning about electric vehicles, you can imagine opening up the bonnet of an internal combustion engine is quite visual. It's quite, you can follow it around, you can play around, see if it works, and the students sort of have grown up looking at the mum and dad's car or whatever, and they end up having an intimate knowledge of how it works. However, with an electric vehicle, if you open up the bonnet of a Nissan Leaf, for example, you see a big black box with some wires coming in, and the students don't have that same intimate knowledge of how these things work and how everything connects to each other and why this works as they do an internal combustion engine. That's what we want to change. Now, obviously, a Tesla has 1,000 volts running through it. A Nissan Leaf is fairly a smaller battery, but still has 400 volts running through it. It's not safe for these students to go in and just play around with a car like perhaps they could do in an internal combustion engine. So we've created these panels. This one in particular here, this is the generic electric vehicle. So the idea to start off with, the students can see how everything is connected up, why these things work, and then get real values from them as well. So if we were to take a measurement over the high voltage battery, not that you would suggest doing that in a real car, but if you were to take a measurement across a high voltage battery, this is sort of similar to a Leaf, so you'd expect about 400 volts to come on this. Now, that would be obviously dangerous for students to be able to do that and get an electricity bill. So you see these multipliers we've got on there. I don't know how well that's coming out on the video, but you can take measurements from here, and then so that's multiplied by 10. So that 39.5 is representing 395 volts. See, that will go up and down slightly depending on how full the battery is. So first of all, you can see how everything is connected up. Take measurements and work, see how it works, including getting real CAN bus values. This big thick blue line is a CAN bus, and you can connect up a scope to that. Well, that is a scope, but it's not connected up to it, but you can get real CAN bus signals and see the data packets and how they come in. So once the students have seen how something works, or how something should work, then we can start introducing faults to them. So if I go into workshop mode here, we can, there's 16
different faults.
16 different faults you can put in, and then the students can start learning their diagnosing skills. We also want the students to be safe, so we've got a real car part for the service disconnect, and a switch for the first responder loop, so the students can learn the process to go through to safely do this. The idea for this would be, before the students are let loose on a real vehicle, it allows the students to be able to do something themselves rather than just watch someone control. So as I said, this is the overview of it, and it's got, well, for example, the power electronics module is this box, and you get the signals coming in and out of it. But if you want to go deeper into the power electronics module, for example, if I pull you over here, we've got the motor and generators trainer, which is a deeper dive into that power electronics module. And so for this, again, it works in a very similar way. You've got test points on there with multipliers, and you can see the pulse width modulation, how that current then goes through into the traction motor to see how that runs. You can see we're driving at 71 at the moment. It also has different feedback options here. So the resolver, absolute encoder, and incremental encoder. So that's something else that students can learn how the motor gives feedback into the power electronics module. And again, similar before, fully functioning CAN bus, getting the signals, and 16 volts coming into that. If we scooch over this side, sorry Chris, would you mind? Thank you very much. So we've got this one here, which is our batteries and charging trainer. So this is, well, really looking at the high voltage battery. So we've got a typical battery here. this is it's a
So this is the area of the battery, yeah?
yeah. So this is a battery here. So we've got
Okay.
8 modules. 12 I think there is. Yes, 12 packs and 8 cells within each pack. So each one of these is the same, but we've only got the test points on here rather than so because they are identical from there. So you can take your measurements here over one module. 4.4 obviously times by 10, so 44, and these are all connected in series, so that would then be double. 8.9, 13.5, so students can see how that interacts with each other. So you've got the
So eight. How much is all together?
all of these.
No. How much altogether is the voltage?
So this will be representing about 400.
400, yeah?
Yeah.
Okay, yeah.
The
35.
battery's low on this one because it's low.
It's consumptions and stuff like that.
Yeah, absolutely. So it's representing a 400 volt battery.
Okay, that's
Again, similar on the other ones. We've got the volts. A clever thing this does, it won't come out so well on the video. You can have a look at the cell balancing. There we go. So if you can see that there. So we're looking at the cell balancing in one of these modules. So what happens with the battery in an electric vehicle, because you've got all of these cell packs in it, if one of them gets out of sync with the other one, with an electric vehicle you're supposed to, the most optimum part of charge is between 20% and 80% charge the battery. So if one of these cell modules comes out of sync with the other ones, let's say it's slightly higher, when you try and charge it up to 80%, only that one that's slightly higher will get to 83%, the other ones stay a little bit lower. Similarly, if you've got one that's slightly high, one that's slightly low, your then window of 20 to 80 then gets shorter because it will only charge to the top one and only decharge to the bottom. So basically what will happen, and we represent passive balancing in this, if you try and charge it up, if you charge it up on AC charging, once it gets to about 95%, then you'll start to see in here the cell balancing happening internally as it does in a real vehicle. Basically what it does, so you can see on there, what can I point to one of those? If I point to that.
yeah.
There we go, you can see that one is slightly too high,
Yes.
and that one is very low.
So they are balancing.
so they're balancing. So what they'll do is they'll get up to 95%, and then because they're still having to charge all of them because that's the way they're connected up, but you'll add then a load onto that one, so it's still charging up at the same rate, but you're also decreasing at the same rate as well. So you're keeping it still until the other ones catch up.
Oh, okay.
You've got that one there. I'm not sure how well I've explained that. The learning materials do that a lot better than I would have done.
Yeah.
But yeah, so it shows what happens with cell balance. And then again, so I said again, 16 faults on this one. Some cells too high, cells too low, faulty connection, etc., etc.
And what about this one? This
here.
module, yeah.
So the electric vehicle charging station trainer. So, I'm just going to quickly show you something here. So the electric vehicle trainer does everything from the plug inwards.
Yeah.
So it has the onboard AC charging. This one does everything from the plug backwards. Okay, so we show that. So the charging station, AC/DC charging station.
Yeah.
So it's everything that happens within there.
Okay, so this is the charging station module.
Absolutely.
Oh, okay.
Yeah.
Okay.
Well, so the green here is the internals of the car, which obviously you have to show as well.
Yeah.
But everything in the blue and white is what happens within the actual charger.
Oh, okay.
With AC charging, it's very simple. AC charging, all of the clever stuff, so to speak, happens within the vehicle. So essentially, all this does as an AC charging is it makes these connect, and therefore it just connects that wire, and then all that goes in, and the clever stuff happens within the vehicle. But more interesting with this one is the DC charging. So the DC, we're in AC at the moment, but the DC charging, it shakes it all the way from the substation, all the way from the source, all the way around here through the fuses, the circuit breakers, the residual current device, RCDs, which can trip it and get faults, AC/DC converter to then take it from the 240 volts or whatever your distribution is up to
800 volts.
800 volts to get it up to charge, and then the way this will work, because it's a 400 volt battery.
So a step up and a step down.
Yeah, it steps up to 800 volts.
Yeah.
Then it goes through this to make it 400 normal.
400 normal.
But really what will happen is it will talk to this having its little control pilot conversation, this will say, well, I'm at 370, so it only ever charged up slightly above it, if that makes sense. So it won't put 400 volts in straight away because that would be too quick a ramp for it, could end up damaging the vehicle. So this wouldn't send out, if this is at 370, this may send out at 370.5 just to sort of gradually step it up slowly. And that's...
Okay.
That's awesome.
Thank you very much for.
No, you're very welcome.